Volcanoes. You all know what they are, you all know what they do. Now let's talk about how they work and why they matter to the marine ecosystem.
So how do volcanoes emerge?
Volcanoes are the result of high temperatures and pressures that work together to melt the rock into magma. Magma escapes through the cracks and weak portions of the Earth's surface to erupt. Thus, two common places that volcanoes form are where tectonic plates converge or diverge. In converging plate collisions, subduction zones frequently occur, leading to the rock being superheated and turned into magma that will ascend and erupt. This is apparent in the volcanoes of the Pacific Rim of Fire. Diverging plates are areas where regions where the plates are pulling apart and magma from deep within the Earth can reach the surface through these openings. An example of this is the Mid-Atlantic Ridge. In both cases, magma breaks through the weakened areas where plates meet and explode in eruptions. The cycle of eruptions will cause the lava that is spewed out to harden over and over, creating layers building up to a volcano. Are tectonic plate borders the only regions of volcanic activity?
The answer is no. According to the hotspot theory, there can be volcanoes forming within the plates themselves. This occurs in fixed areas within the mantle that experience increased mantle melting, leading to higher rates of mantle plumes that will find a path to the surface, creating volcanoes. Due to the inherent nature of tectonic plates moving over the hot, viscous mantle, volcanoes formed from hotspots will typically create chains of volcanoes as the fixed mantle plumes move through a constantly moving lithospheric plate. An example of this is the Yellowstone volcanoes.
How does the formation of new land allow organisms to grow, and what are some examples?
Volcanic eruptions are vehicles for creation of new lands in both terrestrial and marine environments. On land, lava that is basalt or limestone in nature will not only harden to form land, but also be highly fertile for plants to grow in as nutrients are released over time. For example, Naples, Italy. In the water, volcanoes that form can lead to land that rises through the water, climaxing at the formation of an island. Along the sides of the volcano, however, marine life can find hospitable substrate in which to grow. An example of this is the atoll phenomenon, where coral forms along the sides of the volcano and continues growing upward even when the volcano sinks back down below the ocean. This culminates in a ring-shaped coral atoll that survives due to the corals that constantly die but create a surface on which other corals can build on maintaining the integrity of the islands. How do volcanoes aid in nutrient cycling?
Primary producers are critical to the stability of the ocean. They serve as the bulk of the energy that is distributed up the food web. In order to do so, they must undergo biological processes like photosynthesis. Volcanic eruptions are an essential step in the cycling of the nutrients for these processes. This is because when volcanoes erupt, both underwater and on land, they release a great deal of iron, nitrogen, and phosphorus trapped in the molten layer under the crust. Iron is critical for the electron transport chain during photosynthesis. Without iron, the process cannot occur. Nitrogen and phosphorus are both fixed by bacteria and other microorganisms, and the end products are used by photosynthetic algae or plants for further use. When marine organisms die off, they fall onto the ocean floor where nutrients become embedded into the substrate and can eventually get cycled out by the volcanic activity again.
So volcanoes are very interesting, and you can learn more about them at UCLA EEB 109 class.